So today we are going to discuss the global case studies and the best practices adopted by the blast furnace personnel, those who are handling iron ore with a higher LOIs. Now coming to our first case study on this Meisteel China, optimizing high alumina and LOI ore handled by this company case study has been shared. So, welcome to this technical overview of global loss on ignition management. We begin with the Meisteel in China, which faced the challenge of utilizing high alumina, that is 8 to 10%, and high LOI, that is 5.5 to 6.2%, ore in a massive 4070 meter cube blast furnace. Because the traditional Borden composition failed to meet quality target, they implemented a strategic solution. And solution is restricted to using MgO-bearing iron ore pellet with a 4 to 6% MgO addition. Now, by decreasing limestone fluxing and optimizing induration firing profile, Meisteel shows a dramatic improvement. And this dramatic improvement is getting reflected in terms of reduction degradation index improvement by 5% points, and at the same time also our Trumpler index also rose to 88%. So this is one of the way to handle such type of higher LOI in the furnaces. Now coming to a company acts in India, the 10% substitution strategy, how they did the case study is being briefed in a later stage. India X company managed mixed quality ore from Goa and Belgaum, where LOI levels reached to 5 to 7%. It's much higher. To maintain stability, they developed the 10% substitution effect rule. What is that 10% substitution effect rule? For every 10% of burden replaced with sinter instead of lumpur, productivity increased by 2% and the coke ratio decreased by 1%. Their practical burden blend is precision engineered and consisting of 35% sinter and 30% pellet, while limiting high LOI material to just 15% of the total mix. So this is also help in mitigating their earlier issue, and they observe the improvement. Now this approach ensure excellent LOI stabilization and capital efficiency even when using lower grade cost effective stocks. So this is a good lesson for to learn. Coming to the Nippon Steel in Japan, where we can see that Japan utilizes a highly innovative method focused on thermal reserve zone, and by using carbon containing composite agglomerates and basically high reactivity coke, they successfully lower the target TRZ or thermal reserve zone temperature to 820. So significantly down from 1000 degrees centigrade baseline. So we can say that this drop in thermal reserve zone temperature helps in mitigating the issues. So these specialized agglomerates are basically a self-heating, which accelerate reduction at lower temperature, and actually leverages LOI water vapor as an additional reducing potential. So this technology has achieved a coke rate reduction up to 18% and a massive CO2 reduction of approximately two approximately a good number of kg per ton of hot metal. Now coming to our next slide, which is from Brazil Vale, and here it shows that while other manage LOI inside the furnace, Vale in Brazil follow a philosophy of prevention. Their process route involved heavy beneficiation, including crushing and jigging to remove uh, goethite and limonite layers, which are the primary source of LOI. By upgrading the ore to over 65% Fe, they produce pellet with an extremely low LOI of less than a very low, less than 2.5%, and this lead to a world-class reduction degradation index of 6 to 8% and exceptional furnace stability, proving that high quality feed can justify the initial processing cost. So this is a good typical different type of